Tutor, where school is made simple. Let's go.
Completing the square is a useful process when we look at quadratics, specifically conic sections, because they're often in an equation or form that requires us to separate into perfect squares. So the concept then becomes, how do we take a standard polynomial and convert it to a formula with a perfect square? Well, the first question we have to ask is, what is a perfect square? In terms of a polynomial, a perfect square would be x plus a squared, which would then become x plus a times x plus a, which if we then FOIL becomes x squared plus 2ax plus a squared. Now, our goal is to somehow get our x squared plus bx plus c to line up with x squared plus 2ax plus a squared. So in doing so, I'm going to compare our b to 2x. And once I compare my b to the 2a, I need to find out what my a is so that I can then find out what my a squared is. So I will solve for a, which means I'm going to take my middle term b and divide it by 2. And then to find a squared, I'm going to take that b over 2 and square it. Now let's look at this in terms of what we would do in a problem. So if I had x squared plus 8x plus 3, and I wanted to use completing the square here, the first thing I would do is to take my middle term 8 and divide it by 2, which will give me 4. Then I take 4 squared, which will give me 16. So I know that I'm going to come in x squared plus 8x, and I'm going to put 2 blanks here. And then I'm going to put my plus 3. Because whatever I add to this, I'm going to have to simultaneously subtract in order to maintain the equation. So if I add 16, I'm going to subtract 16. Now I do this so that this section here can now balance out. And I know this is going to become x plus 4 squared. And then on this side, I have minus 16 plus 3, which is minus 13. So now I've applied completing the square and found that x squared plus 8x plus 3 is equivalent to x plus 4 squared minus 13.